Hello. Hello, Dr. Pramod. Yes.
Good afternoon, sir.
Yes, good
Sir,
afternoon.
we will start the session within few minutes, sir.
Okay.
Okay, sir.
Good afternoon, everyone. Good afternoon, sir. It is an honor for me to introduce our resource person, Mr. TAPAN Gandhi. He is going to deliver a talk on the topic Opportunities and Challenges in IoT Applications. Here is a brief introduction about TAPAN Gandhi. So Dr. Tapan K. Gandhi is currently working as Associate Professor in the Department of Electrical Engineering and Adjunct Faculty in the School of Information Technology, IIT Delhi. He is also research affiliate to MIT, USA. He received his PhD fellowship obtained his PhD in biomedical engineering from IIT Delhi. He has spent 3+ years as postdoctoral research scientist at MIT, USA. Dr. Gandhi was also awarded an Inspire faculty in the Engineering and Technology category of the Department of Science and Technology, Government of India. During this 5 years tenure, he is awarded as the Excellent Inspire faculty by DST Korea. His research expertise spans from computational neuroscience, brain imaging, communication, machine learning, artificial intelligence. He has papers in top-ranking journals like Nature, PNAS, Current Biology, BIOS Biology, IEEE Transactions. He has 120 publications in international journals and conference proceedings. He is PI and co-PI of nearly 10 crore fund projects from industry as well as Government of India organizations. He has received many awards in India and abroad for his academic excellence and groundbreaking research. His research work is not only published in top journals but also appeared in many popular presses including Time magazines, the Boston Globe, the Times, MIT News, Harvard University, Wall Street Journal, and also in the Science magazine. Dr. Gandhi's work was selected as cover page in Science magazine. He delivered many invited talks in national and international universities like MGH, Harvard University, Yale University, MIT, Copenhagen University, University of Groningen. He is one of the international member to review European Union joint projects on vision sciences. He has 3 patents and 3 technologies transferred to Ministry of Social Justice, Government of India. He is serving as expert member in various research committees in Government of India, UNESCO, as well as reviewers in many journals like IEEE, Elsevier, and Springer, etc. He has also received Platinum Jubilee Young Scientist Award 2015 by National Academy of Science in India and GYTI 2019 award. Presently, he is mentoring an artificial intelligence startup, Naval IT, incubated in IIT Delhi campus. He is also the chairperson of Project Prakash Charitable Trust that helps in restoration of vision, providing education to visually impaired in India. We welcome you, sir. I invite you to give a talk on opportunities and in IoT applications. Thank you, sir.
Thank you, Dr. Pungathai, for this illustrious introduction. Good afternoon, everyone. The title of my talk is Challenges and Opportunity in IoT. Let me share my screen, then I'll start my talk. Can you see my screen? I hope you can see my screen.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Thank you. So coming back to my talk, challenges and opportunity in IoT. First of all, I'll introduce you about the IoT. Then I'll tell you what are the challenges and what are the opportunities working in this domain of IoT. So if I'll ask you that which are the frontiers of engineering, definitely when you will talk about the frontiers of engineering, you will talk about AI, let's say big data, machine learning, computer vision, robotics. In addition to that, another word will come. This is called the IoT, right? And now everybody is very much interested and fascinated about the use of IoT. And because IoT is going to be everywhere, whatever you see around us, you will find the application of IoT in each and every space of our life, whether this is agriculture, whether this is defense, whether this is transportation, whether this is pollution control, everywhere you will find the application of IoT. So if I'll ask you, what do you mean by IoT? And many times when I ask this question, I know this is very simple thing. And people say that, oh, this is very simple. This is Internet of Things. But what do you mean by it? Actually, if you look at the meaning of IoT, you know, this is nothing but earlier we talked about embedded system, right? All of you know this embedded technology, embedded application. So now what we are doing, we are bringing all this embedded technology or embedded system to the network. That means earlier all our embedded system, you know, embedded system is the technology which we developed for a particular purpose, right? And when we are bringing those technology to our network so that they can talk to each other, this is called IoT, Internet of Things. Things means all this object, right? But in my talk, I'm going to coin very, new kind of terminology. Please, remember those terminology and try to work in those domains. Okay, let me introduce one very new terminology over here. Now I talked about IoT. You understood IoT. IoT is nothing but the application. Basically when we are bringing all this embedded system, because I know that you all are aware about this embedded technology. Embedded technology was a very sophisticated technology, let's say 10 years back. And now we are putting those all things even in new bottle, and we are calling this IoT, right? So in IoT, the two most important terms which I'm going to use, one is called the cognitive IoT. Second is I'm going to use the term called the cyber physical system and human in the loop of cyber physical system. So in the broader sense, you just take cyber physical system. And these are the most hottest area of research or hottest area where you can find many jobs in the market. But interestingly, we have hardly many people that who are trained in this kind of area, right? So that's why at least I thought that I should throw this light. Maybe I'll explain you what do you mean by this, so that you can train your student in this area, so that when they'll go to the market, they will get enough opportunity. Not only to get a job, but also if they wish to contribute for the development of the society or to the service of the society, they can come up with many kind of solution for many existing problems. So again, coming back to this IoT, as I told you, Internet of Things in ecosystem of connected physical objects that are accessible through the internet, which I explained to you. And the things in IoT are the objects with IP address. You know, all these devices having certain IP address, and through this we connect or we talk to different devices and we gather the information from it, right? So in the IoT, one of the biggest challenge now is, you know, that we have lots of social media data. Social media, you know, these are all the social media data. And from this data, how better we can find out the information? Can we apply some kind of predefined knowledge, or can we use some kind of intelligence to find out the pattern of it? But interestingly, this is the not only one problem, but if you look at the application of IoT, you will see the one area where the data is increasing leaps and bounds, and those data are called the sensor data, not the social media data. And I'll show you in some, picture in my next slide. Maybe you can see that how this data coming from different sensors are already surpassed this social media data. Again, it's going to be a very huge, challenge for us. So as I mentioned to you, challenges and opportunity. You know that where there is challenge, that challenge will create the right kind of opportunity for you. So always see the challenges as one kind of opportunity. Don't take it negatively, right? So here in this, what I'm showing you here, so these are you just imagine that all these GPS systems are there, and through this GPS system, we are able to connect different objects all together, which are around us, and take the right kind of decision, whether this is for the health, whether this is for the agriculture, whether this is for the defense. In any of this, domain, we can take the right kind of judicious decision. So coming to this broader picture of this IoT, or if we'll talk about the abstraction level of IoT, these are the very crude abstraction of IoT: hardware, data, software, connectivity. So hardware, you know that all these objects means these are all hardware kind of things, right? Which is sensor and actuator. And then through this sensor, it will create huge amount of data, right? And you have some kind of software, maybe this is the system software or application software on which this data, I mean, you will process all this data and find out the pattern. And then also you need the connectivity. That means all these devices should be connected so that the data can be exchanged and accordingly the right kind of action can be taken based on your requirement, right? So this is how these are the abstraction of this IoT. So now people talk about the smart home. You know, in the smart home, this is a very interesting concept. And what you know that maybe let's say you are in US and you want to check the status of your home, whether everything's fine, whether there is, I mean, you can switch on, switch off light even being in US. You can control all the electronic stuff which is present in your house. Even if some burglary will happen or if somebody will enter to your home, also you will get the notification or you will get the alarm, right? So this is one part of the application of the smart home. But interestingly, here I'm going to tell you another very interesting application. You know that India is going to be superpower in terms of because I mean we are talking about the economy is booming or we have the huge amount of Iot human resources by which we can improve or we can increase the productivity of India. But in the back door, if you look at the real kind of scenario, what you will find that all this Iot, those who are the power for India, in next 30 years or 40 years, they would be the old. And now, as you know, that now actually earlier people used to stay together, the parents, the son, daughter, but now the things have completely changed. You just imagine your parents are living in a village or you are somewhere in the city and you don't get a chance to see your parents every day. So, and also nowadays it's very difficult to find out the caretaker. The question is how you can take care of your parents. And here the technology will play a very, very important role. Already is playing and also will play a big role in this kind of scenario. So starting from the healthcare monitoring, looking at the daily day activity. So being even, I mean, away from your home, still you can take care of your parents' health. And this is possible through this IoT kind of application, right? So if you look at this IoT, by 2025, it would be around 12 trillion, $11.1 trillion economy by every year. Whether it's the factories, cities, human, health, work sites, everywhere, you will find the application of IoT. And this is the figure projected by McKinsey, right? So the big question comes that why now we are talking about IoT? Because just like your college is organizing this workshop or FD program on IoT, likewise, many people are talking about IoT. Why now? Because now this is very cost effective, low level of difficulty is very, very less, and high digital need and high availability of resources. So that's why all of a sudden we came up with the idea that let's implement this IoT in every sphere of our life, right? If I'll give some examples. So Barcelona is considered is one city in the world those who have applied this IoT in almost all the domains it's possible. So if we'll talk about the agriculture, this is the precision farming. So in the precision farming, you know that you have the plants, you have, I mean, everything. You don't need any human intervention, but everything would be controlled by your this sensors, right? So basically, the sensors will monitor the health of the plant and when they need water or fertilizer, and accordingly it will deliver. And also you can monitor the growth, and if there is any pest is attacking your plants, also you will be able to know, and accordingly you can take care or you can take the right kind of decision when you are not very close to your farm, right? Here in Barcelona, they use this IoT kind of application, and every year they save more than 50 million US dollar in their parking. If we'll talk about the smart city, I mean the street light, again, all the lights on the street are controlled by the IoT application. That means you need not to switch on and off manually. In India, you know that we do manually until now. So somebody has to switch on and switch off. Sometimes they forget. I mean, the person who is responsible for this thing, they forget that they have to switch off. And in that way, we there is a huge amount of wastage in the power. And the same time, they switch on and switch off not in the right time. So if we can apply this kind of IoT application, or if we can apply this kind of simple intelligence, then it will decide when to switch on and when to switch off depending on the lighting condition, right? So just take an example. When we have a cloudy kind of atmosphere, or when there is rain is going to happen, and all of a sudden you'll see that almost everywhere looks very dark. But edge, and maybe that time is, let's say, 2 p.m. But during rainy season also, it becomes completely dark. Visibility also reduces. The question is, if it is controlled by the human, mostly they will not switch on the light, right? But if it's controlled by the machines, or it is controlled by some kind of electronics gadget, then most probably it will be switched on, right? So this kind of application we need to create for the country like India. Even you can see here, the parks are being maintained by this IoT application, right? And also in this park also they save millions of rupees, millions of dollars. So finally, what you understood, that IoT is nothing but we have some kind of sensing devices. We have some kind of, after sensing, we can create huge amount of data, right? And then when we can create huge amount of data, you have to apply some kind of data analysis to find out some kind of pattern out of it. And when you look at this pattern, and accordingly, based on the pattern, you take the judicious decision, right? This is what about IoT. So what I explained to you, I have just written in the slide. We can track and count everything, which can greatly reduce waste, loss, and cost. Using IoT, we would know when things needed replacing, repairing, or recalling, and whether they are fresh or past their best. Let me give one example here. You know that now we are talking about Industry 4.0. What do you mean by it? In Industry 4.0, we are going to use all kind of intelligence to manage or to maintain the industry or the factory. That means, just let me give you an example. Let's say if I'll ask you that I'm going to give you a job of an engineer. Okay, you'll be engineer in this my factory, and your job is every day you have to check the health of my factory. That means whether anything problematic or you need to replace it. So you have to just every day you have to go and check, and then if it's required to replace, you have to replace. Most probably, initially you might feel that, okay, there is not a very big workload. I can do this very easily. But slowly you lose your interest, because every day when you do this kind of traditional kind of job, automatically your interest will go away, right? And also in the same time, we humans are bound to get tired, right? So this is the beauty of the machine. They don't get tired, whereas we human can easily get tired. So if we'll use some kind of IoT application, so basically let's say maybe computer vision based, or maybe any other sensory system based, what that will do, that will observe each and every unit every day, and based on the requirement, let's say if that unit is not working properly, it will alert the caretaker or the person who can take care of this thing, right? So in that way, you can improve the production of your company. In the same time, you can also manage to reduce the cost in the way, you can prevent some kind of big damage to your factory, right? So in Industry 4.0, we are talking about that how robot can do the manual kind of laborious job what the human is doing. But at the same time, please remember, all this technology what we are talking about, whether it's the IoT or the robotics, these are not going to take the job of the human. Rather, it will create many more jobs for the human. But only what we are going to give to the machine? Only the traditional work, which as a human being, we get tired. So the machine, as they don't get tired, so you can give this kind of job to the machine, right? But in the same time, as I mentioned to you, or as highlighted one word called the cyber human in the loop of cyber physical system, that means we can create this kind of cyber physical system where human at the center of this loop. That means human has to be there, and everything should be done under the right supervision of the human. Only the traditional work has to be done by this machine, and they will alert the human when there is some requirement there, right? And in that way, we can improve not only our own life, but in the same time, we can improve the productivity of any factory or the industry, right? So if you look at this figure, you'll be surprised to know in 1990, we had around 0.3 millions of connected devices. But by 2025, we are hoping that we'll have 1 trillion devices should be on the network, right? And all this connectivity will go beyond laptops and smartphone. So everything would be connected in near future. So whether it's a car, smart home, connected wearable devices, smart cities, connected health, connected life, everything will come up in the near future, right? Everything would be connected. Already it's been connected, but still some domains are still left. But again, the day is not very far when we'll see everything around us will be connected to our life, right? So then the question is, are we moving towards a fully automated world? So this is what I was talking about, that if you look at the number of data being produced by the social media and the IoT generated, you can see here, social media data is nothing in compared to the IoT generated data. So you all must be fascinated about the big data. And earlier when we are talking about the big data, we are thinking that maybe the social media data. But now this IoT is going to generate a huge amount of data, right? You can see here, and this huge amount of data, it's very difficult to handle. I mean, though it's a challenge, I told you this is a big challenge, but at the same time, this when you have big amount of data, you'll get an opportunity to look at this data to find out very interesting pattern out of it. And accordingly, you can suggest what to be done and what kind of action you can initiate, right? So you understood the concept of IoT. What do we mean by IoT, right? I'll give many more examples later. So let me introduce another terminology, what we call the cognitive IoT. So cognitive IoT is again another fascination of the science today. So we are thinking that can we create this IoT network which will behave just like the human being, right? Just imagine if I'll ask you that how much data, okay, let's say if I'll ask you since morning, how many, if I'll record that the number of events you have seen since morning, can you please tell me what would be the memory size of those things, whatever you have seen since morning? Definitely, it would be in the many terabytes, right? But we hardly realize it. So you just imagine you have 5 sensors like nose, ear, eye, touch, smell. Okay. So with this, all this kind of sensor, let's say if I'll replace this sensor by electronic sensor and I'll record all this data, whatever you're getting each and every second of your life, just imagine how much data you are getting, right? But again, the same time, if I'll ask you, do you use all the data in your life? Maybe the answer will come, no, you don't use it. So here the question comes that who is selecting or who is only, finding out which is the data which is required for our life. Then definitely the answer will come your brain, right? So somehow the brain is able to find out the pattern of this huge amount of data and which is only we are using in our everyday activity, right? So this is the beauty of cognitive computing. So basically how the cognition, how the brain work in taking care of all this kind of decision. So I hope you understood. So here what I'm telling, that even the human, we every day we get huge amount of data in our daily life, right? And out of all this data, we don't use all this data, but only we use selected amount of data, and all this decision are being taken by the human. So the question is, the big question is how human is or how the brain is taking this kind of judicious decision to find out the pattern from all this kind of huge amount of data. So here I've written, what are AI and its application? Artificial intelligence is intelligence exhibited by machines and computer system through a set of theories, method, and algorithm, right? AI has a wide range of applications such as problem solving, game playing, natural language processing, speech recognition, image processing, engineering, automatic programming, and robotics. Then the question is, what are cognitive computing and its application? Now, cognitive computing refers to the computing that focuses on reasoning and understanding at higher level and in a manner that is analogous to the human cognition. You understood what I mean? So until now, whatever the AI application we have, these are all rule based, right? But when I'm putting this word cognitive, that means how the brain is taking the decision. Let me give you another example. So let's say today you are in your college and you are inside your office, and all of a sudden, when let's say around 4, your college is going to over at 5, right? And let's say 4:45, if you came out from your main building and you found that it looks cloudy and you can see some lightning is also happening there. So just imagine what you'll do. You will do many things. What you'll think? You'll think, okay, whether I have umbrella or not, how far my home is from my institute, and looking at the condition, can I assume that the rain is not going to happen now and maybe it will come after 1 hour, right? And let's say if you feel that maybe the rain will not occur now and it will take maybe 1 or 2 hours, then you can start from your college and go to your home. But if you feel when I'm talking about the feel means you are getting some kind of information through your sensory model organs, right? And if you feel that, okay, now I cannot go home because it's going to start very soon, right? But yes, sometimes also our estimation also proves wrong. Sometimes you feel that, okay, maybe I can reach my home before the rain starts, but sometimes also it happens in between. But more than 80% time, we are accurate in taking the judicious decision. So the question is, who is taking this decision and how you're taking the decision? Now, maybe your brain is taking the decision, and based on your prior experience, previous knowledge, and the present situation, right? Based on that, you take this judicious decision. The question is that how brain is taking this kind of very intelligent decision. Can we mimic this kind of ability in the machine, right? Even also, I mean, let me give you another example. Let's say let's say I'll throw some new interesting problem to you, which you have never faced in your life. And if I'll ask you, tell me how you can solve this problem. Maybe though you have not seen this problem, but still you try to find out very close to that right answer, right? Or maybe the right answer. So the question is, when you are not exposed to this particular problem, how come you can come up with the solution? So this is what I'm talking about, the cognitive computing. That means how our brain works. So the question is, can we bring this kind of knowledge to the machine, or can we give this kind of knowledge to the machine so that the machine can take the judicious decision, right? In this domain of cognitive IoT, let me give you another example. I hope I'm audible to all of you, because actually in between I should ask you that whether I'm audible to you or not, because otherwise it's very difficult to know that whether you are listening to me or not. Am I audible? Hello? Am I audible? Anyone can answer. Hello?
Yes, sir.
Please respond. Otherwise, you know that when you are giving virtual talk, you cannot see the people. Then it feels that whether I'm connected or I'm disconnected. Okay. So I'm audible and you are able to follow me, right? I'm not going very fast. Hello? Hello? I'm not going very fast. No answer?
Yes, sir. You're not.
Oh, there is some delay in between, I mean, when I'm talking and when you are answering?
No, sir. No, sir.
Okay. Okay, let me give another example. In this cognitive IoT. Just imagine, okay, your college is in which place? This is a Coimbatore, right? Your college, this college, I mean, for whom I'm giving this talk, this college is in Coimbatore or some other place?
Coimbatore, sir.
Oh, Coimbatore, okay.
Yes, sir.
Let's say let's say I am in the college in your Coimbatore and I am living 40 miles or 40 kilometers from your college, right? And let's say I have designed my home using IoT kind of application. And also I have allowed my devices, let's say all my devices are connected to each other. Let's say when I'll start from my college, I feel that now the day is very hot. When I'll arrive my home, the temperature should be around 24 degrees centigrade. And the same time, my TV should switch on based on my mood. Let's say I had a very big argument with the college management because they are not releasing my salary last 1 month, and I'm fighting with them. So I am in very bad mood, right? So when you are starting from your college, that time your all the devices will check that what is your present location. And the same time, the devices will also check, let's say if you are talking to your friend or your family member about whatever incident happened in the college, and based on this, can I predict what kind of mood you have? And accordingly, when I'll enter to my home, automatically my TV will be switched on to some kind of, let's say, some kind of song which will make my mood a little bit of lighter, right? Or maybe, so when I'm talking about the temperature, let's say if I'm starting from, and you know that you, okay, let's say if I'll switch on the air conditioner in my home, maybe if I'll switch on from my college, maybe it will be the wastage of power. So the question is, I should switch on the all this gadget when I'm about to reach, or when the device will feel that during this time interval they can maintain this kind of temperature. So what they will do, they will try to always check my location, where I'm located right now from the GPS data, and based on the traffic and my speed, they will decide that how much time I'll take to reach my home. And accordingly, they will take the right kind of decision, and they will switch on the air conditioner at the right time. Even they can create some kind of environment which will make my mood okay. So this is again a big application of the cognitive IoT. Cognitive means how the human recognize. Let's say if I'll think about, okay, if I'll give another example, let's say when you are in bad mood and when you enter to your home, maybe your mom can sense that kind of mood, and she will try to reduce your pain or maybe your anxiety level by some different way. So the question is, the way that your mom take care of you, can I give this kind of ability to my machine, right? And this is coming under the domain of cognitive IoT. Okay. So this is what I've told you, need of cognitive intelligence. The real value that IoT creates is at the intersection of gathering data and leveraging it. All the information gathered by all the sensors in the world is not worth very much if there is not an infrastructure in place to analyze it in real time. Traditional approaches to programmable computing of processing data using if-then process to arrive a outcome cannot fulfill the true promise of IoT. So until now, whatever IoT you can see, they are doing it by this approach. But what I'm telling you, the cognitive intelligence, this would be the real application of the IoT or real power of the IoT, right? So cognitive system learns from interaction with human and their experience with their environment. This enables them to keep pace with the volume, complexity, and unpredictability of information generated by IoT. It can make sense of 80% of the world's data that computer scientists call unstructured, right? So thus, we are illuminating aspects of the IoT that were previously invisible, finding the pattern, allowing us to make more informed decisions. So this is what we are planning to do. And that's why I'm pushing the term called the cognitive IoT. This is nothing but to understanding the situation. Then from that, we try to find out the region. And based on the region, we try to learn. And this is what we want to make in the machine, right? This is called the cognitive IoT. So when I'm talking about this cognitive intelligence, let me give another example. If you go to any gym, let's say in the treadmill, when you enter to step onto the treadmill, that will try to measure from the sensor, it will try to get your heart data and all the information. And let's say it will have some kind of threshold that if your heart rate goes beyond this level, then the treadmill automatically stop, right? Or, and it may alert the gym staff, right? So this is in a, I can say local level kind of setting, but this is not the real kind of IoT application. But in the other way, because actually here there is no interaction with the environment and only data centric. But in the cognitive intelligence domain, what will happen? When you will step onto this platform, it will automatically based on your fingerprint, it will get your all health records in front of you. And based on the health record, let's say if you have started, doing some kind of exercise, in the same time, it will measure your heart rate or maybe any other, let's say, galvanic skin response or any other parameter. And based on that, it will see that whether you are all right or not. If something will go wrong, automatically, the same time, it will alert the doctor, it will alert your family people, and also it will send your health record to all these concerned doctors. And they can take the right kind of decision and they can save your life if it is in the danger zone, right? And this is how the cognitive intelligence is different from simple intelligence. Okay. So you understood the difference between cognitive intelligence and in cognitive intelligence. So that's how I differentiate AI. So whatever you know AI, these are not real AI. But if will bring this cognitive AI, that would be the real kind of AI. So we are until now we don't know how to create the cognitive AI. That's why people are working in different way to find out the solution, right? So I hope that you understood the basic concepts. So then what we are planning to do, we need to invent, build, optimize, operate, innovate, then finally we enjoy and try to make our life beautiful. And whatever we do in the domain of engineering or science, these are to make our life more beautiful, right? And finally, the day is not very far when we can have this IoT everywhere, right? So coming to this point, so as I told you that these are the challenges. As I told you, these are the, you understood the concept. And also I told you, what do you mean with this IoT? What do you mean with this embedded system? And what is the relationship between embedded and IoT? And then I talked about cognitive IoT. And also I highlighted you the cyber physical system, human in the loop of cyber physical system. But here, the biggest thing I introduce you, the cognitive intelligence. That means how the brain works. So if we cannot understand how the brain works, most probably we cannot come up with the right kind of technology which we need in near future, right? Because you know that when I'm talking about smart health, humanoid robot, smart car, smart mobile, digital security, everywhere in all sphere of our life, you will find that everything are interconnected, and that will decide our quality of life, right? So before that, so the biggest question is, we need to understand the brain, that how the brain encode information. And the same time, again, if I'll talk about many other intelligent activity in our human brain, one of the intelligent activities, the cross-modal information linkage. Cross-modal information linkage means, you know that people see any kind of sophisticated robot nowadays, still they are lacking in this cross-modal mapping. Cross-modal mapping means how they fill in one sensory model in the other domain. Let's say you are holding a mobile phone. Even looking at the mobile phone, you can feel it visually, that how it looks, right? So let's say when you are talking to your friend, let's say you are talking to a friend over mobile phone, but when you're hearing the voice of your friend, still you can visualize how your friend looks like. So this is again another example of this cross-modal mapping. That means you are able to map from the auditory domain to the visual domain. So these are all important aspects of the brain. The question is, can we understand how it's happening? And if we can understand this mechanism, most probably we can create the machine like this. So we have a unique opportunity to address this kind of problem, because as I told you, where there is problem, where there is challenges, that will create a very big opportunity for you to look at this problem and create the solution for it. So likewise, as I mentioned to you, that these are the very two sophisticated problems, and we came up with one idea, that how we can understand that how the human brain is encoding the information, right? Or how our sensory modalities are talking to each other. But interestingly, if you wish to understand this kind of mechanism, what you have to do? You have to do research since the baby takes the birth. Let's say after the baby took the birth, and if you do some kind of experimentation, most probably you will be able to answer some of the questions in this domain. But interestingly, what we found that there is no research on this domain. Then we ask ourselves why this kind of research is not there. Let me give you one example. Let's say if I'll ask you that tell me, let's say all of you in front of you, you can see your computer or mobile phone, right? And if I'll ask you, what is this device? You might say, oh, this is my computer or mobile phone. But if I'll ask you, how did you know that this is the computer? Most probably you have the answer, my teacher taught me or my family members taught me this is a computer, or I know by myself. But if I want to understand the mechanism, how my brain encodes this information. So let me give another very simple example. If I'll show you two different objects, right? When I'll ask you what are the two objects, you can tell these are two different objects, but you cannot tell that, oh, they are the same object, right? So the question is how you are able to distinguish two different objects. So this is the beauty of the brain. Even when we see some known person from unknown person, we can do it very easily, right? And this is the beauty of the brain. And if your brain will not do this job, most probably you won't be able to differentiate any objects in this world, right? So here, this is a very interesting question, how my brain learns all this kind of thing, right? So this is the question also came to our mind around 15, 20 years back. And we thought how we can answer this question. As I told you that in order to answer this question, you have to work on a newly born baby. After the birth of the baby, if you'll do some kind of research, most probably you can answer this question. But interestingly, you cannot do research on a newly born baby for two reasons. First thing, the ethical committee will not give you a chance to do research. And the second thing, the baby will not understand what you are going to do, right? That's why there is no good research on this problem. Then we came up with one idea. We thought that is it possible, let's say if somebody born blind and has not seen anything since birth until the age of, let's say, 15 years, and now he is adult, 15 or 20 years, right? Last 15 years, he has not seen anything. So the question is, let's say if by miracle, we restore the sight to this person, and then if we'll do research, most probably we can shed some light on this problem, or we can find out some kind of way, right? And we found very interestingly, because we are from India, we know our problems better than anybody else, right? And you will be surprised to know that 1 in every 100 Indians is blind. And you will be surprised to know that nearly 50% blind population of the whole world, they live in our country. And the blindness, there are different problems are there. I mean, these are the main causes for the blindness. Corneal scarring, that means if there is any injury in the cornea, then the person will be blind. Cataract, when somebody has a cataract, then the person will be blind. And by birth cataract, he would be blind. Retinal dystrophies, that is retina disconnected from the cornea or the other connections. Infections, you know that our mothers, mostly people live in the village, and most of the mothers, they deliver their baby in their home setting. And even in the village, the dispensary, they are not properly sanitized. And that's why the chances of infection is very, very high. And due to this infection, the child, they took birth with this kind of blindness. Okay. And also, you know that there is a virus called the rubella virus. And that's why when the mothers are pregnant, they are supposed to take the vaccine for the rubella. But hardly our mothers get vaccinated. And due to this kind of problem, the child, we have a huge number of blindness in India, right? But interestingly, out of all this blindness, 40% blindness can be treated or cured. But due to the lack of knowledge, lack of facility, we are not able to restore the sight to this number, 40% of this blind population. So, and due to this blindness, many people, the blind children, they have very huge difficulty. So their lifespan is always 15 years less than their normal counterpart. Even those who take the birth, those who are born with blindness, 50% of the blind children, they don't get a chance to see their next birthday. That means they die. And when somebody born blind, their education prospect is also very less. And hence the employment prospect is also very less. And due to all this problem, in India, we are losing around 10 billion US dollar every year because of the, because they are not very productive. And because of this problem, we are losing this amount of money. So here the pressing humanitarian need is to providing treatment to this curably blind children. You can see here this child is blind. Okay. So the question is whether the child, if will do some kind of intervention, whether we can restore sight or not. So interestingly, before we start this work, nobody attempted this problem because of this critical period hypothesis. So again, as I told you, that always when there is a problem, it always have some kind of opportunity. So from this big problem, also we got a huge opportunity. So this two gentlemen you can see here in my slide, their name is David Hubel and Torsten Wiesel. They got Nobel Prize in 1981. And they got Nobel Prize for a hypothesis called the critical period hypothesis. That means in our life, we human beings, we start learning all this concept since birth. Let's say after the birth, our neurons are very hazy in nature. And within few months or few weeks, they get specialized for different function, right? That some neurons should be dedicated for the hearing, some neurons should be dedicated for the vision, like this. Let's say you born all right, and after your birth, I'll put you in a dark room, and in that dark room, I'll provide you food, drink, everything, but you are not allowed to see any lighted part of this world. And let's say I'll put you in the dark room for, let's say, 2 months. And after 2 months, when I'll bring you to the lighted part of the world, by that time, you will lose your ability to see. Can you imagine? So they conducted many studies on the animal, and this is what they observed. And that's why they told that if somebody born blind and has not seen anything the past few months or few years of their life, that means the chance is very less to restore sight to them. And that's why, and they published many very big paper in Nature, Science, you can see. But interestingly, we found a clue. They did all the experiment on the animal and they extended the study on the human. Then one question came to our mind, what about human, whether it's possible or not? And we started a project called Project Prakash. This is a humanitarian scientific quest. And Project Prakash, the meaning is to bring light in the lives of the blind. That's why you call Project Prakash. And it's headquartered in New Delhi. And this is being founded by Professor Pawan Sinha, who is professor at MIT, and with whom I did my PhD. And we both started working on this project. And what we do outreach. Outreach means we have a big team, and they used to go to different states in India, UP, Madhya Pradesh, Haryana, Rajasthan, which are very close to Delhi. And then we screen all the children, and we bring the child, those to whom we feel that we can restore sight. You can see here, this is the screening is happening in different places in different parts of India. And then we provide the treatment. We do some kind of surgery, and we put some kind of intraocular lens. And then after that, we do research. The first question is whether vision develops after sight onset. You can see here, this is a 21-year-old person, right? Here, I'm showing you 8 years and 22 years. So the question is whether the brain has ability to change again in the later part of life or not. And if we'll do this kind of surgery, whether the person can see or not. And you'll be surprised to know that nearly in last 10 years, more than 10 years, we have restored sight to more than 700 blinds in India. So you can see these are the snapshots of the few people, those who were blind, but now they can see like you and me. But at the same time, when we restore sight to them, we get a unique opportunity to do many interesting kind of research, which are very helpful in the medical science and at the same time in the domain of computer vision as well as artificial intelligence. So I'm not going to highlight all the study, I'm just one for the sake of your understanding, I'm just throwing some light on one study, let's say imaging study. So we use this kind of scanner, this is magnetic resonance imaging. We put the subject when they're blind and we take their brain images. And when they see, after the surgery, when they start seeing this visual world, we again take images at different point of time. And I'll explain you what we mean by this. Okay. Here I'll explain you one kind of study. I'm not going into deeper into the study. Let's say, actually, okay, after getting thousands of images of the brain, we process those images and then we try to find out the pattern out of it. So here, this is the only visual cortex. Visual cortex means the back part of the brain, which is responsible for the vision. What we see, these are being done by the back part of your brain. Okay. So what I'm showing you here, the red color, this red, blue, these are the neural firing, right? So T-2 means when the person was blind and when the person came to us. T+7 means 7 days after the surgery. T+30 means 30 days after the surgery. And T+120 means 120 days after the surgery. So what you can see, T-2, here the neurons, you can see two big blobs. Let me put my pointer, you can see. Yeah. So here you can see there are two big blobs, right? So that means the neurons are, here firing in a very coherently or cohesively. T+7, again, these big blobs are still there. But after T+30, you can see after 30 days of the surgery, the neurons, this activation are getting smaller. And 120 days, you can see there are many small hotspots. So what does it mean? It means, in the computer science or electrical or electronics, when we talk about the encoding principle, let's say if I have 2 bits of information, right? 2 bits. And if I'll ask you in how many ways they can encode the information. So many of you will say 2-way, many of you will say 4-way. Both answers are correct. So if my 2 bits are dependent on each other, then they will encode either 00 or 11. If my 2 bits are independent in nature, then they will encode in 4 ways, 00, 01, 10, 11. That means when my 2 bits are independent in nature, they are encoding more information. Likewise, here also, initially the neurons are either firing or not firing. That's why we can see only 2 big islands. But along the timeline, what is happening after 120 days, the neurons are getting more independent, right? And when the neurons are getting more independent, they are encoding more information, right? And this is, what we found from all the subjects. And this is one hypothesis was given by Horst Barlow. Horst Barlow is great grandson of Charles Darwin. So in 1989, he came up with this theoretical paper, and nobody knew how human brain encode information. But we are the first in the world to tell how human brain encode information. Then, as I told you, the multimodal information linkage, how we fill one object in one domain to the other model. Let's say here the child is holding the mobile phone, and when the child is holding the mobile phone, how he's translating those features to the visual space, right? And this is one of the example of the cross-model mapping, and which is one of the most important part of the artificial intelligence. So here what is happening, when the child is holding this mobile phone, I'll show you. So actually, okay, this is a very interesting question, was posed by Molyneux. So Molyneux is a great scientist in 17th century. He wrote a letter to John Locke, or he wrote in this way. Let's say today I am born blind, okay? And today I'm blind. Today I'm blind, and you taught me that this is a cube and this is a sphere. And I learned this concept by touching these two objects, right? And imagine tomorrow I get back my sight. And when I get back my sight, if you'll ask me, without touching these two objects, can you tell me which one is what? So the question is whether I'll be able to tell it or not. And this is a question asked by the Molyneux in 17th century. And in last 300 years, many scientists attempted to answer this question, but there was no answer, correct answer. And because of the intensity or because of the power of this problem, in the Stanford Encyclopedia of Philosophy, it's written, there is no problem in the history of the philosophy of perception that has provoked more thought than the problem that Molyneux raised in 1688. So in this sense, Molyneux problem is one of the most fruitful thought experiments ever proposed in the history of philosophy. So finally, we conducted some experiment in this cross-model mapping. I'm not going to talk, actually, this is a very difficult thing to explain you, how we conducted the experiment. Maybe if I'll get a chance sometimes in future, and if I get a chance to come in front of you, most probably I can tell you more about this thing. But just remember, whatever the question was asked, and finally what we found that just after the site onset, they are not able to tell which one is what, right? But interestingly, what we found, within 7 days, they learn this concept. So even, what they see and what they touch, they cannot correlate within just first few days. But after 7 days, mostly all the subject learn this concept. This is called the cross-model ability. And because of the richness of the result, we published this paper in Nature. And the day when we published this paper in Nature, it appeared in the cover page of the New York Times. And New York Times mentioned that the Indian blinds could answer 300 years back question. And it has very, very high significance for the domain of machine intelligence. How? I'll tell you here. Let's say here, the child is holding this mobile phone, and we are getting some kind of haptic features, which we call H1, H0, Hn. And we are also getting some kind of visual features like V0 to Vn. And here, the brain is somehow establishing a map between haptic features to the visual features. And then finally, the child is able to map from one sensory modality to the other modality, right? So here again, I did one experiment to understand this mechanism. Let's say when we watch the television and when somebody reads some news, we feel that the voice is coming from the mouth of the speaker. Speaker means, let's say, this person. But actually, the voice comes from the speaker, electronic speaker, which are placed behind the television or the side of the television. But the question is, why we feel that the voice is coming from the mouth of this person? In order to understand this mechanism, what I did, I recorded the voice of this news reader, and at the same time, what I did, I divided this whole visual space into different, let's say 1000 by 1000 voxel, and I try to observe each and every voxel on the screen, that how that voxel is changing with respect to time. And here, let's say the red color is the trace of my voice signal, and the blue color are, let's say, all the small voxel what I'm getting from the visual space. And when I correlated with all this space, I created this kind of picture. What I found a very high correlation around the mouth, which represents by the red color, but very cool correlation in the other area. Because of this high correlation around the mouth, we feel that the voice is coming from the mouth of this person, not from the speaker which are placed at the side of the television, right? So from this, we can create a lookup table. You know that computer science, we call the lookup table. Let's say for the mouth confusion 1, we have the sound 1. For the mouth confusion 2, we have sound 2. Likewise, if you can create the lookup table, at the end of the table, if somebody will give me, for this mouth confusion, what would be the sound, I can easily tell. So from this kind of experiment, what we found the dynamics of the environment play a very important role to learn or to develop this kind of reasoning-based knowledge. That means, let's say, those who are working in this domain of artificial intelligence or the robotics, in the robotics, what we do, we program the robot at the first day, and we feel that in this way, my robot will behave as intelligent as the human being, right? This is completely wrong. Even the blind child, those who, they are not even child, they are, let's say, 20 years old. After the sight onset, still they are not able to map one sensory information to other sensory domain, right? And that takes at least 7 days. Then how come we can feel that the first day I can program my machine and my machine would be smarter than ever? So from all my experience, what we understood that we should not program the robot at the outset. We should give very basic preliminary knowledge, and we should force our machine to learn by its own. And in that way, we can create the right kind of machine for the future, which would be the next generation of cognitive artificial intelligence based device, right? So coming to this conclusion, so what I mentioned to you, that first of all, we need to understand the mechanism of how the brain processes all this intelligent information, and based on that, if we'll build a machine, most probably, or build technology, most probably we can create the next generation technology, which will be really going to solve many real-time problems, right? And again, I'm telling you that where there is challenges, there is opportunity. As I mentioned to you, we started working on this challenging problem, and it creates lots of opportunity in the domain of AI and also in the domain of health science, in which we are contributing a lot in terms of research and fundamental knowledge. So because of this kind of richness of our research, my research being when it published in PNS is another top-notch journal in the world. It got highlighted in the Hindu. Even our research is highlighted in the Wall Street Journal, the cover page of the Science magazine. You know, Science is a very top-notch journal. Even one magazine from the Germany, Geo magazine, they covered story from my lab. You can see here my students are working on the kid. Also, our research is published in Nature, Times Magazine, Harvard and MIT News. As well as the Netflix is also covering some stories from my lab when we work to understand the human intelligence. And finally, you can see here the beauty of this is what Albert Einstein said: those who have the privilege to know have the duty to act. That means you can see the left side picture when the child came to us being blind, and after the sight onset, when the child can see the world, this is the difference you can see. So there are many problems like this where you can bring science and humanity together. So many of the times we do science, but we don't know how my science or engineering is going to help the society. But this is a very interesting kind of example where you can see science, technology, and humanity can walk hand in hand. So we have a trust here. So we don't only treat the blindness, we not only, recover or help them to see this world, but also we try to educate them. And for this, we try to raise our own funding through the donations, because these children are very, very poor. So we spend all the money which is required for their surgery, even for their education. So now here I would like to thank all the subjects who took part, in our study, and because of them, we are able to answer many interesting questions of the science, which is not only helping the medical science, but also contributing in a big way for the development of AI systems. Thank you very much. And in this way, if you will approach the problem in this way, you can have a broader impact on your society. Thank you for your time. And if you have any questions, you can ask me. Any questions? Any questions? Hello? Hello? Your voice is very less. Hello? Can you hear me?
Yes, sir. Yes, sir. We can be able to hear you.
Yes, sir.
Yes, now voice, yeah. Any questions? No?
If you got any questions, you can get it clarified from sir. Or you can even put your queries in the chat box.
Yeah. I think there is no question from your participants.
Yes, sir.
Okay. So with your permission, can I take leave? Actually, I have another meeting from 2:15. So
Okay, sir. Okay, I express my sincere thanks to our speaker, Tapan K. Gandhi, sir, for presenting his wonderful topic on the opportunities and challenges in IoT and artificial intelligence. It was more informative, engaged, and insightful talk, sir. Thank you, one and all.
thank you. Thank you very much. Okay.
Thank you for accepting our invitation
Thank you. It's my pleasure.
and be a part of this online workshop. Thank you, sir.
Thank you. Bye.
Thank you. TechUp3 sponsored 2 days online workshop on IoT and machine learning algorithms towards smart ecosystem has finally come to an end. We are in the final session of this workshop. I am happy that all of you have taken interest in registering this workshop and having attended this course for the past 2 days. I congratulate all the participants being part of this workshop. I hope that all of you should have been benefited by the lecturers. At this juncture, I would like to thank TechU for sponsoring this workshop. This workshop has been made possible with the continuous support from our management, principal, and our head of the department, Dr. A. Rajeshwari ma'am. I thank each one of them for their motivation and support. I would like to thank my organizing team for their immense support in the conduct of this workshop. Now I request participants to share their views and suggestions regarding the entire course. Your feedback is very important to us. So please come forward to put your views and suggestions. Participants can share your suggestion and views towards the workshop. Any suggestions and comments from the participant sides?
Good afternoon, ma'am. This is Shana from Department of AIML CIT.
Good afternoon.
Uh, yeah, good afternoon. Ma'am. I would like to thank the Department of CIT EC for organizing this webinar series on IoT and ML. Actually, IoT is new to us because this is not the area that we explore as computer science faculty. Okay, but they
Yes,
have
ma'am.
given all the experts who came have given very good, simple explanation about what IoT will know what is the IoT technologies and where this AI or ML will fit into that particular domain. And we have a lot of applications where we can work on is what I gathered from this particular 2 day session. And I personally thank the department head and the coordinators and the management for having given us an opportunity to participate in this particular workshop. Thank you, ma'am. It was a
Thank you.
nice session. Thank you.
Thank you. Thank you. Thank you. Thank you, ma'am. Thank you for your comments and suggestions. And I assure you that each will be given consideration so that the future course will be even more of a success. Okay, I have posted attendance form and feedback form in the chat box. So please fill the forms at the earliest. We will send you the workshop PPT material, video link, and certificate within a week time to your mail ID. Thank you all. Thank you for the participation.
Thank you.
Thank you. Thank you, sir.